Hey guys, welcome to day 15. Today we are going to start talking about something big, halfway through the series. We are going to go into more data structures. And so far we've only done 2 data structures. We've done arrays and dictionaries. And basically, if you don't know what data structures are, like big word, they are containers that hold data. And so in our array, we had data like in each index, but our array, it held like multiple numbers. We didn't have to create like 5 different ints, 5 different variables. We could create one array and then at different indexes of the array, we could put different things. Our dictionary was also a container because we could do like a key and a value pair, put it inside the dictionary, put as many of those as we wanted in there, and that was great. It held our data without like making us create a single variable for each thing, which is like crazy cool. So what data structure is next? Well, you probably already know from the title of the video, maybe you've heard of them before, but basically we are going to be talking about linked lists. What is a linked list, you may ask? Well, a linked list is a data structure, so it is a thing that can hold data, a container, and it consists of a group of nodes which represent a sequence together. And so what does this mean? Well, let's go to the real world. Let's not worry about these technical terms. And so I want you to think of a train. You're going from New York to Boston, Boston to New York, and so you're just, you're going on your little train. But say, your friends on this train, and so you go to a different train car. A train is made up of multiple train cars, and each train car has, say, a different amount of people in them. So train car 1 may have, 5 people in it. Train car 2 may have, 100 people in it. Everyone wants to be in train car 2. And then you have train car 3, which is like the elite train car. And so maybe you have like 20 people in it that are like super posh. They do their thing. They have their tea, they have their coffee, they're cool. And then you have car 4, which is full of like, I don't know, a bunch of other people, college students going crazy. You have these different cars and they have different, things in them. Well, this example just got way longer than it should, but basically in code, we could represent this train as a linked list, and then each train car as a single node, because the whole train itself would be like the sequence of train cars, which are the nodes. And that's basically what a linked list is. It's this big sequence of smaller nodes, and the order does matter here. Whereas with a dictionary, it didn't matter. And with an array, it did matter, but we were limited on space. Like on creation, we only had this amount. But with trains, you can like add as you go. Well, guess what? With our linked list, we can add as we go to the train, and there's going to be some kind of order to it. We're going to have like a first element of the list and a last element of this list. We won't be able to index it quite like we do our array, but we'll work something out. And so to go into this a little deeper, our train cars, they come in a special order. You can't just swap them in and out, which is why the linked list is a great representation of this. They have a singular order. You can't have train car 4 automatically be train car 1, unless of course you remove train car 1, 2, and 3. And so this is where the details come in. And so basically each node, each train car is composed of data. Say the data is how many people are in that train car. And then also with this data, we have a reference. And so inside each node, we have this data thing saying how many people there are, and then a reference to the next node. And so it's a reference to the next train car, a link to the next train car, so that we can, access the next thing in the list or, in the sequence. So basically we have this train, which is a linked list, a sequence of train cars, which are like the nodes. And then in each train car, we have a data saying like, this is how many people are in the train car, and then a reference, like if we're in train car 1, it might have a reference to train car 2, and then train car 2 will have, 5 billion people and a reference to train car 3. And then you'll do that until you get to the end of the list where the last train car, train car 7 doesn't have a reference to the next train car because, it's the last one. And this fact will be very helpful in doing code. So I've talked a lot, I talk a lot in the beginning and then we do cool things. And you want me to do cool things? We're going to do cool things. And so we will open NetBeans. Per usual, we're opening it. And so what are we going to do today? Are we making train cars? Kind of. We are going to actually implement a linked list ourselves. And so this idea of you have a sequence of nodes that are connected together, we're going to implement this in code from scratch. And so we're doing this from the bottom up, So we're going to close these programs up and we are going to create a new program, and it's going to be called linked list. And so we'll do new project, like we always do. And this is all good to go. And inside of our desktop, we are going to create a linked list class. It will hit enter. It'll load up, do its thing. And then inside of our linked list, we are going to have two classes. We're obviously going to have our linked list, which is like, big project. It's our train car. But inside of our linked list, we want to have nodes of some sort, our individual train cars versus our big train. I hope I said that this linked list is our train, nodes, train cars. If I didn't say that, that's what I meant. And so if we go to new Java class, we are going to create a node class. And this is just going to hold each, train car, each node. But we're making this a little bit general so that this doesn't have to represent train cars. It can represent anything that's in a sequence. And so we'll have the linked list as a sequence, and then each item in the sequence is like the node. But the node is not data, because the node holds the data and the reference to the next node. Kind of sinking in? I hope so. And so inside of our node class, this is where we're going to start. We start with the pieces and then get to the bigger class usually. And this is usually how you'll do your programs. You got to know what the pieces of your code are before you build it all together versus starting at linked list. Like, I don't even know what my node does. How do I know how to use it? Well, we have to define our node. And so in our properties, we are going to do, like I said, we're going to have a reference and then a data. And so the reference is going to be a node, and we'll just say next, the next in the sequence. And then we are going to have an int data. And so here we are assuming that our data is an int, but it could be a string, it could be whatever you want. And when we learn about generics, I feel like that's on day 20, and so if you want to skip ahead to that video, if it's come up, yet. Basically, generics will allow this to be any data type because you'll put type D here, and then you'll do this thing that's like here, and you'll say this extends object or something, but that's for later. Don't worry about that. I'm scaring you. I know, I'm scaring you. Okay, so we're going to say all data in our node, it has to be an int. And so these are our properties, so we'll do a little comment that's like our properties. And this class is going to be fairly simple. We are going to have two constructors, and what do you think they are? Well, we do public node int new data, and we do int because we know our new data is going to be an int, and then we do what we always do in here. We do data equals new data, and then we'll just do our next equals null because we don't know what our next thing is going to be because we didn't provide it in our constructor. And so we're going to create another constructor. We'll do public node int new data, and we're actually going to be able to provide a next node. So we'll have node as the data type, next as the next node that we're going to, and of course we set it all up with data equals new data, next equals next. And to make this a little bit more clear, we can do new next instead of just next to prove that it all works, and that you can't, like from the last video, you can't access new next out here. It's gonna freak out and be like, oh, what's the symbol? Kind of, okay. So up here we have our methods, and then we'll say a little space, we'll say constructors, then we'll do another space, and we'll do getters and setters, and these are going to be our usual things. These are going to be so helpful later on, so highly recommend you implement these. And we'll do public int get data. What do you think this does? Well, it returns an int. We have an int data here, so we will do return data. Pretty obvious. Next, we'll do a public node get next. What do you think this does? Obviously gets the next node, and here we're going to do return node next, and we're really just going to write next. And so what do we do next? Our setters, and so we are going to do public void set data, open close parentheses, open close curly bracket, and here we are going to have a parameter int new data, and then we're going to set our data, our current data, to the new data here. And so there we go, and then we're going to do public void, and we can't write things today, so I'm going to scroll down here, and we're going to do public void set next, and of course it's going to take a node, new node, we're setting a new node for our next, and so we'll have to do next equals new node. And notice if we set our node initially to just equal new node and then just put data here, we will have to call this constructor set next before we can call get next, because if we do get next, it will return null, which could cause problems later in our program. Or, it could mean we're at the end of the list, but we will get to that later. But it's something important, to think in your mind, think back to. And so what does this mean? Basically, it means that each node we create is going to have a next node reference. It's going to have a data that's associated with it. So say, train car 1, the next train car would be train car 2, and then the end data would say you have 5 people in it. And so if we go down here, if we call get data on that first train car, then we will return with 5, which is the int. That's how many people in the car. That's what we're representing as our data. And if we did like train car 1 dot get next, it would return train car 2. And then train car 2 would itself have a data, property and value. And so say it has 1 billion people in it, then it would, if we did like get data on the second train car, then we would return 2 billion people. And then get next on train car 2 would be, train car 3, and then using this like sequencing, we will be able to get access to everything inside of like our train, our linked list. You get this, you're smart, okay. So going back to our linked list, we have a number of operations that we can do on this, theoretically. If we have a linked list, we have our train. And so in our train, we should be able to add cars, we should be able to remove cars, we should, be able to get like how many train cars are in, the train. There are a bunch of different things that we should be able to do. We should see like if there's anything in the train. Is the train empty? Are there no train cars for the train? And we should be able to like retrieve data maybe from these train cars. So say I want to know, okay, how many people are in train car 3? 2. Okay. Well, being able to do that would be key inside of our program. And so here we're representing, like I've said before, the data is going to be the number of people in the train car. And so let's implement this. The first thing we always do is our properties. And what's the second step? Constructors. And then the third step is methods. And so that's going to be how we're going to attack this data structure. And we're implementing a data structure. That's crazy. Like usually we just, use arrays, use dictionaries, but here we're actually creating our own, which is crazy cool. And so the property of our linked list, what are they going to be? Well, first we're going to have a node head, and then we're going to have an int count. And so what do these mean? Basically, we're going to have inside of our linked list, we're going to have a reference to the head. And because inside of our node class here, we have inside of our head, which say is the first train car. And because we're computer science, we'll say it's the 0th train car. So basically, if we have the 0th train car, we know we have a data, property with a value and say it's 5 people, but we also have a next reference. And so we, as the 0th car, have a reference to the first car. And then the first car has a reference to the second car. So all we need in our linked list is a reference to that first, train car. And then because of the way nodes work, we'll be able to access everything else in the list by doing get next, set next, stuff like that. And then why do we need this count? Well, we need to know when we're going to be at the end of the list. So it's good to know like, okay, how many train cars do I have in this? Okay, I shouldn't like go out and above my count of like how many things I have in this linked list. And so that's it for properties, super simple. And then as for constructors, we can do a public linked list, and we can just create a whole new linked list where the head is null. We don't have anything in the list, so the count will be also 0. Another thing that we could do is a constructor where we have a public linked list, and inside of here we're given the node head, so we're given the first node, and then we can say head equals new head, and we'll change this to new head, and then we can say the count equals 1. So we can initialize our linked list with 1 object or with 0 objects, there we go. Now our methods. Well, what did we say we want to do? We want to be able to add things to the list. We want to be able to get things from the list, like retrieve, data and stuff like that. We are going to want to be able to get the size of the list. We are going to want to know if the list is empty. And we're going to want to know how to remove things from the list. And so we have add, get, size is empty, remove. We are going to implement all 5 of these. I can count 5 of these today. And so the first method on our to-do list is the add method. And so first thing is always the signature, which is just kind of like this part of the code, and which is always this part of the code. And so we are going to do public void add. And then inside of the parentheses, we are going to do int new data. So we just say, I want to add a train car with 5 things in the list or 7 things in the list. We'll just put in 7 as our new data. And then inside of here, we will actually add it to the linked list. And so how do we do this? First, we'll have to create a new node with this new data. Then we'll have to figure out like where the list, like currently, where it ends, and then set like the next reference of say there's like 6 train cars and this is train car 7 that we want to add. Well, we'll have to set train car 6 is next to train car 7 because that's the thing we're adding, because previously train car 6 didn't have like a next thing because it was the last element. And so there are 2 things. First, we have to create the train car 7, and then we have to set these train car 6 next reference, you know, in here of our node, our next node, we'll have to set that to our train car 7 for it to be, you know, a part of the list rather than this isolated node. And so let's do this code, you know, let's do it. And so the first thing we're going to do is node temp, because this is going to be our temporary node that we add to the list later. And this is just going to be new node. And how do we create nodes? Well, we can go to our node class here. We have this constructor here and it says int new data, next null. Well, we can do that because we have the data here, int new data. So we'll do new data. There we go. And then in the next line, we're going to do something a little kooky, a little crazy. We are going to do a node current, which is going to be like our current node, and we are going to have that equal the head. Now, let's think about this for a second. This is going to be a little weird, a little odd. Basically, what our add thing is going to do is it's going to go, like starting at the head, it's going to go through all the elements of the list until it gets to the end. And then when it gets at the end, it's going to take that last node and set its next to the new node that we just created. And so to do this, we are going to use a while loop, and we're going to do while current dot get next, open close parentheses, is not equal to null, meaning like once we get the once like current.next equals null, that means we're at train car 6, because if it's null, that means we're at the end of the list. There's no next node in the sequence. And so what are we going to do here? Well, we're going to do current equals current.getNext. And basically what this is going to do is it's going to allow us to iterate through the list. So now let's say, like going through this, our current is head. So say head is like train car 0. So then we do train car 0 dot get next, train car 1. Train car 1 is not equal to null. So then we have our current is now train car 1. Then we do train car 1 dot get next is train car 2. Then we have train car 1 right here in our current. And so we get next of train car 1 dot get next, we get train car 2. So now current is train car 2. Then we do train car 2 dot get next in our while, because we come back up here. So this is train car 2 dot get next. That'll be train car 3. You get the pattern. And so when it finally comes to say train car 5 dot get next is train car 6. So then we do train car 5 dot get next, that's 6, and so train car 6 will become current. Train car 6 dot get next will be null because they're only, you know, 6, train car 6 is the last guy. And so when that equals null, then we know, okay, we want to do current dot set next to be our temp data. We want to set the next of, you know, train car 6 to be this new node that we created. And because this doesn't return anything, we are done. Fantastic. All right, but of course, you know, I forget things. Because we add something new, we want to do count plus plus because we have something new to our list. One more thing before I move on is that here in our constructor, we allow ourselves to create an empty linked list. If we go down to our add and we do current.getNext, that's going to error if the head is null, because you can't like call a method on a null thing. This is going to be very key later, but it's incredibly important because I had a programming assignment like when I was taking a class called 102, and thank God I had great friends that knew how to do computer science before I did, and I didn't understand the fact you can't do this if current is null. If current is null, it doesn't even know what .getNext is. Yeah, it used to be, you know, a node, but if head is null, like .getNext doesn't exist because current doesn't exist. But if current exists, if current is, you know, train car 6 and the next thing is null, like that's cool. But if you're trying to do like current where current is like train car 7, but train car 7 doesn't exist, it's going to freak out, error. So this is a problem that we have possibly created. So we are just going to comment out this constructor so it doesn't happen. And so when we create a linked list, obviously we have to have at least one element to create it. We're not going to be able to create an empty linked list. And so if you're interested, you could actually edit this method so it does work if the head is null. How would you do that? I don't know. Hint, hint. If there's only 0 elements in the list, then the one element that you add is going to be the head. And because it's also the end of the list, then the count is going to be 1 and its next is going to also be null. So all you're going to have to do is create a new node with the data and then set it to head, change the count to 1, and you're done. Feel free to pause the video, implement that, but we're not going to do that here. Okay, get, of course, what do we do first? We do public int, get int index, because we want to, be able to say, I want this thing, add an index, and I want train car 5. Go get it for me, and go get the data that's at that train car. Well, that's what this is going to do. So train car 5 has 6 people in it. It's going to go get train car 5 and return 6. That's what we're doing. Cool. So what are we going to do? Well, we're going to do if index is less than or equal to 0, and we're going to say return -1. And so -1 is going to be like the value we return when we don't know what to return. And so let's say a train car, like it can't have -1 people in it. It can have 0 people in it, but it can't have -1 people in it. And so by returning -1, we are going to say like, oh, the request that you had is invalid, and so what I'm going to return to you is invalid either. This is kind of a tricky, hacky way to do things because the proper way to do this would be to return null. But it's going to error because null is not an int, so we'll do return -1. And so this is a hacky way to get around this. The best way to do this would be to throw an exception, make it so like the program kind of errors and lets you know like, oh, that's not a proper index, but we are going to do exceptions later. They're a big topic in error stuff and testing, and we're going to talk about it later. Do not worry. So for now, we'll just have this value that it returns that we know is invalid, but guess what? Our request is invalid, and so we can, we can do invalid things. If the user does something weird, we can return something weird back. And so inside of our get method, we are going to do the same type of iterative thing here. We are going to do node current equals head. And what are we going to do? Well, we're going to go through the list until we get to that index. And so we are going to do a little for loop here. We're going to do for int I equals 1, semicolon I is less than index. Then we'll do I++. Then we're going to open and close curly brackets. And inside of these curly brackets, we're going to do current equals current.next. And so why? First of all, this needs to be get next. Okay. So why am I starting at 1? Well, let me tell you, it's important. Here we are going to say our index is the number in the list. And so say I don't know, our index that we entered is 1. Well, here we'd have 1 is not less than 1, and so we would return the head. And so it's the first element of the list. That is how we're going to be dealing with these lists. So if I want the 6th element, it would go and get the 6th element, not the 5th. Where if I wanted the 5th element, I'd have to enter 5 because we're starting our counting at 1, not at 0. Kind of makes sense? We're going back to normal counting just for this for loop. And so, of course, we get to the one we want. What do? Well, we return its data. So we're going to return current.getData once we're at the proper, node inside of the sequence. And we use this whole current idea and the get next idea to get to our, the one we want inside of our linked list. Okay, size. These are going to be easier. So we'll do public int size, open close parentheses. What do you think this is? It's very simple. Let's scroll it back up here. Let's look at these properties. What do you think the size of the list is? It's a count. We're just going to return the count because that's the size of the list. And then for our isEmpty, what do you think this is? And we're going to return a Boolean because that's what isEmpty returns. We'll do isEmpty, open close parentheses, open close curly brackets. We're going to return either true or false depending on something. And so we know the head is the first element of a list. What if the head is null? That means there is no first element of the list. And so if the head is null, then our list is empty. So we could do head equals null. There you go. So what will this do? If head is equal to null, it'll return true. If head is equal to false, it'll return false. But with our given constructor, we have to create it with one element. Well, we can uncomment this once we fix our add, which I'm going to let you do on your own. But of course, we could continuously remove things until our head is null. That's another way we could get to empty. And so let's implement our remove. How do we do this? Well, we'll do public void remove, open close parentheses, open close curly brackets. And what this is going to do is we're going to remove from the back of the list. And so when we remove something, we have, like, say our big train, we have train car 1, 2, 3, and 4. When we call like train.remove, we're going to remove the fourth car of the list, and then we'll still have train cars 1, 2, and 3. If we want to remove train car 1, then we have to remove train car 3 and train car 2 to then remove train car 1. Kind of makes sense? Okay, here we go. Well, the first thing we do with all of these, we do node current equals head. Feel free to pause the video if you kind of know what we're going to do here. We're going to somehow traverse to the end of the list. And by traverse, I mean get to the end of the list by using .getNext. And when we get to the end of the list, we will find like the second to last item and set its next to null. And when we do that, there will be no reference to our, like, the next item. And so say like the last train car is 7, the second to last train car is 6. Well, train car 6, its next, it will be set to null. Train car 7 will no longer be a part of the list because it can't be accessed by train car 6. And the only way that these like nodes are strung together is through .getNext. And so if .getNext of train car 6 is like empty, it's not, nothing's there, well then you can't access train car 7, and train car 7 will be caught by the garbage collector in Java, and it will be, taken away, removed. There will be no way to get it, therefore it is removed from the list. And so how do we do this? We'll do while current.getNext does not equal null, open close curly brackets, and inside of here we'll say current equals current.getNext, open close parentheses, semicolon. Then down here we will do current.set next to null, and then we'll do count minus minus. So basically what we're doing here is when we get to train car 5, say, we'll do train car 6, like it goes, the last element is train car 7, next to last train car 6, then the next to last, train car 5. So that's like the order of this. And so if we're at train car 5, .getNext is train car 6, .getNext is train car 7, we're all good. If we're at train car 6, it will be train car, and then we like do this, of course, and then we set, of course we do this, and then we set train car 5 to be train car 6 with this whole .getNext thing. So then we'll have train car 6, .getNext would be train car 7, .getNext would be null. And so therefore it would be equal to null, so it would get out of here. Our current would be train car 6, and therefore we would set the train car 6 to null if we were trying to move train car 7, and of course we decrement the count because we have one less thing in here. Possible problems with this algorithm is that what if this .getNext is null? So what if the head is the only element in the list? So we have head .getNext is null, then we get the next of that null thing here. That means this implementation won't work for a list that's 1 or less of length, because we'll have head.getNext, okay, that's null. .getNext of a null thing will error and freak out because you can't reference null things. So that's a problem you could think of. If you can think of a way to solve it, feel free to mess around in here. But thinking about like what these .getNext pointers are like referencing and how they're linked, like that's going to be key to all of these methods. And so this was like hard. This was hard stuff that we just did. We had to really think about how our nodes were connected, how our linked list was connected, but now, it's done. And I'm going to tell you a little secret. What if I told you everything we just did is already built into Java? You didn't have to create your linked list. It's already built into Java. Java knows what's going on. Well, if we go down here to our main and we do linked list open caret string close caret linked list equals new linked list open caret string close caret open close parentheses semicolon, we are going to have an error because our class is named linked list, and so we're going to change this to linked list us because it's our linked list. So we'll have us there, and it's going to freak out, so we'll rename the file. All will be good. We'll build, we'll go down here. Okay, We had a little bit of trouble there. There we go. Okay. So basically linked lists do live in Java, but because we were like overwriting linked list, it was freaking out. And so we had to change this to linked list.us. It could be anything else. And then we go down here, we had to import something, and so we go up here, we do import java.util.linkedList, and notice it imported the class, not the whole java.util. It only gave us what we needed for right now, which is great. And so yeah, they exist. Linked list dot, oh my god, you have all of these methods. You have add element, you have clear, you have clone, you have everything. You have get first, get last. You have so much stuff in here, it's ridiculous. It's so ridiculous how many methods you have in here. So you didn't have to do all this, and all of the little problems that we had with the referencing in here, guess what? You don't have to deal with that. It's built into Java. But the fact that you tried it and that you know, like you built it from the bottom up and you kind of know what's going on, you know it's, like now you know, okay, linked list, I can add stuff, I can remove stuff, and you can actually, instead of just removing from the back or the front or adding to the back of the front, you can do it at any index. But we only, implemented adding to the back because, it's easier to do in 30 minutes. But check this out, you get all this stuff. And so you could represent your train car as, a bunch of nodes. And here, like, you don't even know the idea of node exists. You just know you have a linked list and you have like a linked list of strings. Like, that's what you think it is, but really it's a node. Like, this is how it works inside of Java. But it's all abstracted from you when you do this little method. You don't even know what nodes exist. Isn't that crazy? You now know something deeper in Java that isn't given to you in this IDE. All right, so let's mess with one here. So if we do add, we could do add Alice, do a little semicolon, and then do like system.out.println, linked list. There we go, run it. What's gonna happen? It has Alice in the thing and it prints it out gorgeously for us. What if I add another thing? What if I add like linked list.add Alice, and then print this out again? Printing out, save. Alice, Alice. There you go. And it looks kind of like an array, but notice we aren't limited on how many things we can put in here. That's the advantage of using a linked list. They're connected by links, and so there is no like end space for it. And of course, you can explore and mess with all of these different methods, but I'm not going to do that now because I feel like it's getting long. So that's it for this video. Today we talked about linked lists. We learned what they are, and they're basically like this data structure, this container that holds data, and each like thing of data is a node, and each node holds a reference and then the data, and then all of the nodes that are strung together, that is what makes up the linked list. We actually made a node in a node class, and then we made a linked list, like actually implementing a data structure, which is crazy awesome. And then we learned, we did all that work for no reason because they're already built into Java. But in Java, like you could have no concept of the idea of node and how they're connected and still use it, which is a little scary, but also really cool because that means you can use other things and not know about their implementations. And by abstraction and hidden implementation, I mean like there's code that you don't know about that's there and you can still use the method and not even know about what's going on behind the scenes. So yeah, one thing I didn't talk about is that in our like list here, we created like a singly linked list, and so that means like we could only go one way in the list. We could only go from the head to like the last element, the first element to the last element. But you can actually create doubly linked lists, which are like you can go from the head to the tail or the last element, and then you could also go from like the tail, the last element, to the head. So you can iterate both ways. And so you have like a previous, like in your node class here, like you're gonna have a node next, and then you'd also have like a node previous. And then you would do a bunch of stuff there, like down here, but that's hard and it gets deeper into harder stuff. Yeah. So I hope you learned something in this video. You are officially halfway done with 30 days of code. Oh my god, congratulations. You know so much stuff, it's ridiculous. Like you could probably quit the series now and be fine and like know what's going on. But the second half of the series is like, okay, I know how to code now. Like, how do I become a better programmer? How do I become more efficient? How do I use data structures to my advantage? How do I create programs? Whereas the first part of it is like, what is computer science? What is code? What are computers? And so that's it for this video. The HACKERRANK challenge is down below in the description, and if you have any questions, feel free to leave a comment on this video. I hope you learned something, and I will see you tomorrow.